In this video, we're going to talk about parabolas, and a parabola can be defined as a symmetrical curve that is approximately U-shaped. When we say a parabola is symmetrical, we mean that it looks the same on either side of a vertical line, and we call this vertical line the axis of symmetry, or the AOS. A lot of my students ask me, why do we study parabolas? And the answer is that we see them naturally in everyday life. For example, if you shoot water out of this fountain, the path of the water will assume that of an upside-down parabola. Parabolas are also important in ballistics. So for example, if you shoot a rocket vertically straight up in the air, eventually gravity is going to take it over and the path of the rocket will assume that of an upside-down parabola. And perhaps the most stunning example of a naturally occurring parabola is the rainbow. Parabolas are also seen in man-made structures, such as these beautiful stone arches, and perhaps the most famous man-made parabola is the Arch of St. Louis. Now, Jack and I would like to pose a quiz question to you folks, namely, what do the following two occupations have in common? The first is a jet fighter pilot, and the second is a conductor of a symphony orchestra. And the answer is that both of these individuals have a lot to worry about all at once. Look at all these instruments that the pilot has to keep track of, and this conductor has to know what each of these musicians are doing. It turns out, however, that when you study parabolas, you only have to worry about three things. You only have to consider three characteristics of the parabola, and here they are. Whether the parabola is facing up or down, what is the shape of the parabola? Is it wide or is it narrow? And finally, what is the location of the vertex? And the vertex can be described as the turning point of the parabola, and the vertex always has a definitive xy coordinate. As shown here, it is 3, 1. So let's take these one at a time. First, is the parabola right side up, or is it upside down? Pretty straightforward. Second, is the parabola wide, or is it narrow? And when we use the terms wide and narrow, we use them in reference to this parabola on the left side of your screen, which has the equation y equals x squared. If the parabola that you're looking at is more narrow than the reference parabola, then we use the term narrow to describe it. Conversely, if it's wider than this reference parabola, it is known as a wide parabola. And the reason why y equals x squared is the reference parabola is because the coefficient of the x squared term is 1. And as you'll see, when this coefficient changes, the width of the parabola changes. Specifically, as this term gets greater than 1, as the coefficient gets greater than 1, the parabola becomes more narrow, and when it becomes less than 1, as in a fraction, 1/2, 1/3, it will become wider. It turns out that all parabolas are derived from this reference parabola. They start out as y equals x squared, and then the vertex gets moved, the width or the shape gets changed, it gets flipped upside or down, and it changes into one of the parabolas that you see on the right-hand side of your screen. It is very similar to a cheese pizza. Every pizza is derived from the cheese pizza. The crust is changed, thinner or thicker, various toppings are placed, but at the end of the day, all pizzas derive from the cheese pizza, and all parabolas derive from the reference parabola y equals x squared. So we've already looked at, is the parabola up or down? Is it wide or narrow? Now let's take a quick look at the location of the vertex. As mentioned before, the vertex always has an xy coordinate. And when we look at parabolas, we use the letters hk to correspond to those xy coordinates. It turns out, ladies and gentlemen, that all of the characteristics we've been talking about, is it up or down? What is its shape? Where is the location of the vertex? All of these characteristics, the details can be found in this vertex equation. And for the rest of this video, we're going to focus on this vertex equation. We're going to bring in a high-powered microscope, and we're going to dissect this equation. We're even going to bring Jack in here. And by the end of this video, you will become an expert at all the information that this vertex affords. It's important to know that the equation that you see is a generic form. What you will be presented with in your homework or in quizzes are real-world examples. Notice that in the real-world example, the x and y value, the letters x and y are still present. What changes are the a, h, and k values. The goal when you study parabolas is to look at the equation that you're presented with, your real-world example, and identify what are the a, h, and k values. Now, why are the a, h, and k values so important? Why do we need to find them in any equation that we're presented? Well, the answer is the a, h, and k values are going to determine whether or not the parabola is up or down, whether or not the parabola is wide or narrow, and where is the vertex. Each of these parabolas have different a, h, and k values. So again, the shape of the parabola, the location of the vertex, whether it is upside down or right side up, will be determined by the a, h, and k values. All of these parabolas have different a, h, and k values. It's important when you're presented with the real-world example to identify the a, h, and k values. And how do you do that? You pattern match. However, sometimes you're presented with an equation like this. This equation is not in vertex form. How do we pattern match this? Where is the a, h, and k when you're looking at the equation y equals 4x squared? Well, here, ladies and gentlemen, you use hidden ones and zeros. Here, if you look at this equation, it is really y equals 4x squared. When you break it down like this, or I should say expand it out like this using hidden ones and zeros, then it's clear that the a is 4, the h is 0, and the k is 0. Another example. Real-world equation, not in vertex form. You cannot pattern match this as is. What do? You bring in your hidden ones and zeros. Once you do that, it's clear what the a, h, and k value is. Finally, the all-important reference parabola. This is not in vertex form. However, when you bring in hidden ones and zeros, it's clear that the a value is 1 and the h and k value are both 0. So let's summarize what we've learned in this video. Parabolas are a symmetrical U-shaped figure, and the reference parabola is y equals 1x squared. All parabolas are derived from the reference parabola. 3 characteristics to worry about. Is it up or down? Is it wide or narrow? And where is the location of the vertex? All of these characteristics can be found in the vertex equation. And it's important that you are able to find the a, h, and k value even if the equation is not in vertex form. Now in our next video, Jack and I are going to show you how to take these a, h, and k values and turn them into a parabola. How to move from the reference parabola to any one of the parabolas that you see on the left side of your screen using the individual a, h, and k values found in the equation.